Morning, everyone. So my name is Lucas, and I will do a hitchhiker's guide to a trustless automation protocol right now. My name is Lucas. I'm head of go-to-market at Mimic. I have been with the company for over 18 months right now, and we have been focused on building on-chain automation for the past 4 years. So we can call ourselves experts in this area. So just put the context to start, set the floor here. So what do we mean by automation? So as a user, we mean it, to interact with blockchain without any manual intervention. But as a developer, you think of it as, okay, I want to execute code in a blockchain when specific conditions are met. So we're going to go through the journey where I'm going to tell you a little bit more about the protocol that we've built, and what sort of features we have built in to it and how developers can use it. And I'm going to have a little helper. That's Marvin. If any one of you read the book or seen the movie, The Hitchhiker's Guide to the Galaxy, you probably know Marvin. If you haven't, you should catch up. It's a really classic book and movie. So we're going to go through the automation protocol, but let's not forget about trustless and decentralization, because that's one of the reasons why we're here in Web3, is because we want things not to be centralized, and that something that we don't need to trust because it's trustless. We're going to start with a simple interaction like scheduled transaction. So let's think of a simple transfer that you want to automate. Alice wants to send funds to Bob. And you need to do this. You need to trigger this on a specific time. You could use a cron job to do this, and you could potentially use some centralized tools like Gelato or OpenZeppelin Defender to do this. It's a simple thing. That's why we're starting with simple features. So we have got schedulers in the protocol that you can use. If we want to go a little bit more further into this, you want to check the balance thresholds. So you want to do the transfer, but only if there is more than X, tokens or in the account, in the address. You need to query balances beforehand before you automate this transaction. And again, you could use potentially Gelato or Defender for this. So we've added thresholds so you can check them. Next thing is token prices. So okay, you want to make this transfer automated, but only if there is a more than $1,000 worth of value of a token. So in order to do so, you need to check the rates between the two tokens. You could use some on-chain oracles if you want to build it yourself. You could use Uniswap TWAPs for that. But why build it yourself? We have token rates embedded into the protocol. If you want to go a little bit more, deeper into this, like you want to have any token prices. So a lot of tokens, especially if you want to trade, meme coin to meme coin, or like go into some exotic tokens, you're not going to have those tokens, those token prices on chain. Not all oracles provide those. So for any weird token prices, you need to have off-chain sources. Because on-chain sources are not always an option. You need some off-chain data for that, and it has to be trustless. That's important. So we've added off-chain data sources into the protocol that you can use for your automation. Going further, okay, we've discussed transfers. It's pretty trivial, I would say. You don't want to automate transfers only. You want to go definitely more deep than that. So DeFi is probably one of the most important aspects that you would want to automate. So stuff like tokenized operations, swaps, bridging, lending, investing. You could yourself integrate some dexes. You could use aggregators. You could spend hours on integrating different DeFi protocols. But why would you do so? We've covered you for that, and we have added DeFi integrations where you can automate any tokenized operations, basically. But again, this is DeFi. We want to be more generic. We don't want just swaps. We don't want just transfers. We want to do anything, basically. You want to execute any function on the protocol that a smart contract can support. So things like arbitrary calls. If you wanted to do it yourself, you would have to program each of these, audit. Again, a lot of time spent, a lot of resources required. This is not scalable. So we've added generic calls to the protocol. Custom triggers. That's another cool feature that we've covered. So if A occurs on chain X, perform B on chain Y. So you can have different triggers that you check some on-chain events on one chain and then you execute on another chain. So arbitrary event triggers. You could use crushing oracles for that, but we're getting like super complex in terms of developing these. And you could rely on some trustless data sources. But again, why would you? We've added those custom triggers into the protocol as well. Going even more important, execution, trustless execution. So storing the keys to execute these operations are risky. We don't want to store our users' keys. We don't want to do this. This is like a common security risk right now if you're trying to automate something, because you have to have those keys stored somewhere, and you have to give the access to a relayer or to a third party to do so. We want to avoid storing critical keys. We have to validate the conditions on chain, and anyone could execute our code in a trustless way. So we've added a trustless execution that I'll explain how it works when we get to the protocol infrastructure architecture. And lastly, we want this to be easily updatable, because in today's world, when you create an automation, it's often fixed. Like making changes is super complex. So we want to allow you developers to change the rule. So change is the rule, not the exception. So we want to be able to update triggers. We want to be able to update conditions. We want to be able to update operations, stop executions, and scale executions in a matter of changing few lines of code and not the whole infrastructure. So the code is updatable in the protocol. So now what? People usually think automating is a simple thing, but those who hasn't actually gone into deep automation don't know how complex it is. Like writing custom smart contracts, scripts, deploying relayers, making sure they have gas, giving access to private keys, and if you want to do something new, you have to kind of go all over the process again. We've added all those features to so basically all those features show you that it's not a simple thing, and that's what we call Mimic protocol. That's the features that we have built into the protocol that we're building. So what is Mimic protocol? Mimic protocol is a 3-layer solution to simplify how you interact with the blockchain. Layer 1 is a planning layer. So a user, a developer implements their own tasks. Today, the tasks can be written in TypeScript, so you don't need to know Solidity, you don't need to know any smart contract knowledge. The TypeScript code is getting transpiled to WASM. Soon we're going to add libraries to support Python, Rust, and other languages. You decide, you write your own logic, basically. You decide how you want to trigger them. And then you get the access curated data from oracles, and the execution is delegated to relayers. So in a simple manner, you write the task, you define all your logic, you sign it with your wallet, and then it goes into the protocol. The protocol does all the monitoring, checks the oracles, checks the prices, makes sure that your conditions are met. And when they are, the protocol creates an intent on your behalf. And that's how we get to execution. So there is no user intervention required. We're leveraging intents to do so. So whenever your task conditions or triggers are met, the protocol creates an intent. The intent is being auctioned in the protocol to multiple solvers that are competing to fill it, and obviously to give you the best price, the best execution, the cheapest one, the most efficient. You as a user don't have to care about like if you're going to be using Uniswap or 1inch, or if you're You're going to be getting if you want, define a yield percentage, and you don't care if it's morpho, if it's compound or Aave, you can like kind of abstract all of this. So the intents are getting executed based on the best proposals, and then we go to the third layer, which is the settlement layer. So basically, the settlement layer makes sure that the solving from the solver is matching the intent that the task that you've created. So we have got some on-chain safeguards that will make sure that the solution from solver is matching your request in the task. So we have settler contracts, we have some safeguard engine. You can also add custom safeguards where you say, okay, I don't want any transaction above this amount to happen, or I don't want to withdraw this funds or transfer this funds to any other address than X, for example. So you can do a lot of those on-chain safeguards to ensure that your tasks don't go as not intended, basically. It's all checked on blockchain. So you get this like enforcement. The solver, when they solve the transaction for you, the intent for you, they have to provide a proof to the protocol that there is a match between the intent and the execution, and then the protocol checks it on your behalf. If for any reason it would not match, then the execution would fail, and basically the task will kind of keep going. Our main goal here is to push for standard. As I mentioned, we've been building on-chain automation for 4 years. We've processed over $7 billion in automated manner for our customers. We have like a large B2B suite of customers that we're building custom automations for. Everything is built, in kind of semi efficient way where we're utilizing smart accounts, we're writing scripts, we're like writing tasks ourselves, and we've had a lot of customers coming to us for very custom solutions, like very custom use cases. And even though we can automate anything, it was like, it's taking too much time, it's not efficient, it will cost our customers of the developers time to do so. So that's how we come up with Mimic Protocol, because we want a standard that we can use ourselves, but then we also want to open it for everyone in the space to use it and to make it easier for developers, basically, to automate on-chain tasks. So Mimic Protocol alpha version is live now. You can access it on live. It's working on 4 EVM networks. Important to mention, we're EVM right now. We're also working on the Solana deployment. So currently, the protocol is deployed on Arbitrum, Base, Optimism, and Gnosis chain. So you can basically go into the docs, and through the docs, you'll be able to generate your API key and create your own task, define the task, and get it running to have it tested. Thank you very much for listening, and let me know if you have any questions.